Well, good morning. It is in May already. Happy May Day. Actually, it's May 2nd, and we are getting close to being done. We have a pretty big quiz tomorrow, or our next class. So you are going to want to brush up on the review topics, on how to find different angles and arc lengths. Today we're going to talk about something really simple. Well, it's not really simple, but just a review over Pythagoras' theorem. And so we'll get started on that right away. All right, so the one proof here today is that if we have a tangent line here, so here's a tangent line. Remember, a tangent line only touches a circle one time, right? At one spot. If it touches a radius, okay, if it touches a radius, we know it forms a right angle, or what we like to call perpendicular. Okay. Oh man, I just want to say, Michaela, we miss you, and actually, I don't know if we miss you yet because the class hasn't started, but hopefully you're having fun, and whoever it is that you wait at the door for in the morning, I'm sure they miss you already. Anyways, so we got our tangent line. We got a radius, and it's always going to form a parallel line. I know what you're saying. You're saying, I don't agree with that. I think it's probably not true. Well, let's see. Let's put this somewhere else. Let's see. Where is it going to be tangent here? All right. Okay, well, it's not going to touch the radius here. All right, let's see. I'm not going to be able... Oh, yeah, I will be able to swivel this around. And let's see, right there probably is about where it would touch the tangent line. Does that look like a right angle again? I do believe so. I do believe. So wherever you put that tangent line, whenever the radius meets up with it, you're going to have a perpendicular line or 90-degree angle, which is nice because I can use SOHCAHTOA or I can use Pythagoras' theorem, and that's where we're headed next. All right, so we've got this RP. We know RP is 15. All right, so I'm going to start labeling. So it says, and these should be lines. I'm sorry. And in your notes, you should do this too, just to be right. Right. RP is 15. Okay. It says AP is 8. Look at that red on blue. That looks like superhero colors. It's a superhero type of day. It says find RA. What's the distance of RA? Well, guys, thankfully I know I got a radius meeting up a tangent, which means, I have a right angle, which means I can figure this out using Pythagoras' theorem. Now don't forget, Pythagoras' theorem is a squared plus the b squared, that little b, he's so squared, equals that c squared. Alright, it just sounds like cuss words, doesn't it? That a squared. You're an a squared. No, you're an a squared. You're a b squared. You c squared. I don't know. Anyways, alright, so I've got, let's see. Well, here's my right angle, and I know my right angle always points to my hypotenuse, which is always c. So actually, I don't know what c is. I don't know what c is. But I do know what the other ones are. And remember, the other ones doesn't matter which one's a and which one's b, so I'm just going to go 15 squared plus 8 squared. And I could have flip-flopped those. I could have done 8 squared plus 15 squared. 15 squared, everybody knows, is 225. 8 squared, everybody knows, is 64. And then I know that equals c squared. Alright. Everybody with? Everybody following? You're following this Pythagoras theorem.
5210.
Hello? Is that God? Okay. 225 plus 64. 225 plus 64 equals 289. Alright. So 289. I know that's going to be 289 is c squared Now this takes a long time. So what is C? Well, then I do the roots of both. So I know the square root of 289. Everybody knows square root of 289 is... You guys know what it is? It's actually 17. I got my handy dandy calculator just to double check that. Alright. So I know RA, so the distance of RA is 17. It is 17. Alright. Now it says, what's RT? What? What's RT? I know who JT is. He sings Cry Me River. Well, what is RT? What is RT? Alright. So. Okay. Well, if the whole distance from here to here is 17. Okay. Now, I actually know something else. Can you guys spot it? I actually know. Let's see if I can grab this sucker. Oh, I can't. I actually know that AP is 8, right? And isn't that going to still be 8 right there? Isn't that 8? Right? AP is 8. So, I'm going to go 17 minus this 8. So 17 minus that 8, and I got 9. So would you believe that 9 and 8 gives me 17? So RT is 9. Perfecto. Alright, we got to cruise. Alright, next one. Got another Pythagoras' theorem. This looks like a hypotenuse again. Alright, that right angle. So I am going to go 6 squared plus the 8 squared should equal... That's C squared. That's 36 plus 64. And everybody knows that's going to be 100 equals C squared. I'm telling you, we're going to mull through this fast. Now, how do I figure that out? Well, I square root it. So then I go square root of 100, which everybody knows is 10. C equals 10. By the way, that is a C up there. C. Okay, so C is 10. Does that seem about right? Could that length be 10? I do believe. I do believe. Got my McDonald's. By the way, this is in the morning. I've never shot a morning one. But I'm shooting it now. That's right, I'm shooting it now. Alright, let's try. Last one on our first sheet. Ooh, we want to know this little guy right there. Okay. Well, I want to find this hypotenuse. So I'm going to go, alright, because that's a hypotenuse. I know this is my right angle here. So my hypotenuse is here. So that's going to be C. So I'm going to go 16 squared plus 12 squared. Now I know these, but do you know what they are? That should equal C squared. Alright. 16 squared is 256. 12 squared is 144. And that's going to equal C squared. Now 256 and 144, I believe that is 400. So that's C squared. Now remember, how do we get rid of that little square hickey? Not the kind of hickey you're thinking, but the other square hickey. We're going to square root that sucker. That's 20. Sucker, huh? It's kind of funny. C is 20. Oh my goodness. Alright, so C is 20. That's not the answer though. I know this is 20. Alright. Now I'm trying to find this little guy. Right here. Well, remember, I know the whole length across is 20. And how far is this? Well, that's the radius, right? And I know the radius is 12. So I can either go 20 minus 12, and that'll give me that answer there. Or I can say, what plus 12 gives me 20? And you should say 8, right? 8 is the answer. Why is 6 afraid of 7? No, we're not getting started doing that. All right. Good, 7, 8, 9. Okay. So that's that. Guys, is this kind of making sense to you? Sensicles? So I'm going to do that. And here's your homework. And there's a couple different things. Now, obviously, I didn't give you an example where we didn't know, or we only knew hypotenuses. And there are some decimals here, so you're probably, probably gonna wanna like do some other stuff here. But here, this one I actually don't know my radius. Okay. Well, I know this is my right angle, so I know actually C. Let's say I know my A and I know my C. I don't know. Let's say I don't know my B. So now this one I would go like 12.6 squared plus B squared equals 17.4 squared. Right? Because C is always my hypotenuse. That's the only thing you got to remember. Okay. So you can set that up. What is 12? 12.6. I would love to see you guys do this without a calculator. That's 158.76.
The card still blank. Please call 5210.
There they are again. Equals 17.4 squared, which is 304. I should probably go ask if I'm subbing today. I might have to sub today. 76. Alright, and then I just solve for b squared. So I'm going to go take that minus my 158.76, which is 144. So b squared equals 144. And so obviously b equals, everybody knows, 12. That was a fancy number. I like that when it happens out nice like that. So b is 12. So the radius is 12. So you guys get the drift. I want you to work on this and work hard and love your neighbor as yourself. Bye.